Hello everyone, this is Zhibing. Please let me introduce my robot. I have spent almost a month on this project. The goal is to have this robot at home while I am in the office. Then I can control this robot through the cloud and make it to move from one place to another place while it's streaming the video information to me. In that case, I could see the house from different corners. Um, I think this is a cool idea. That's why I built it. But maybe it's not a cool idea. But anyway, so this robot, as you can see, is made mainly those parts. One is a mechanical base with two DC motor, and also has a wheel on the back side. So these three legs make it pretty stable while it's moving. The reason why we choose this, it has more space. The second thing is relatively simple control, and, comparing with those DC balance motors, it had only two wheel. You have sensor to control them. It's relatively more complicated, and that's the mechanical part. The second part is the power source. It's a lithium-ion battery, 12 volt, nominal, and there is a Jetson board running Ubuntu, and it has two server process. One is doing the initialization and and establish the peer-to-peer video streaming, and the third thing is trying to establish the control channels, low latency control channels. And the second process basically accept all those control information from the first server process, and then talk to the Arduino board through the USB serial interface. The Arduino board then controls the two DC motors here. The reason why we only use DC motor is we think the user can look at the thing through the webcam and control the motor accordingly. So we don't have to give them a specific location or fixed location for it to move. So they can look at the thing and adjust the position as on the fly. So I think that's a goal, and also it makes the whole design relatively simpler. Okay, so let's power on the device first. Looks like it powers up directly. Okay. Looks like it powers up. So as I told you earlier, there's first server process has three major functions. The first thing, it's talk to the signaling server in the cloud. Is trying to tell them the signaling server about properties of the board, the codec profile, everything. And on the other side, there's, like, for example, the laptop also talk to the signaling server. Then they do a three-way SDP answer and call process. Basically, exchange the media information. After that, they started to do the peer-to-peer connection from Ubuntu board to the laptop. Most of the time, peer-to-peer will work, but in the case you have a private firewall, the traffic will be blocked. In that case, there's another approach using the turn server. Basically, it's not a peer-to-peer. The signal will travel through that turn server to the device and back forth. So that is more that costs more in order to get the turn server, and in this case we are purely demoing the peer-to-peer case. Okay, and it works in most cases. All right. So as I said, right, I mean, there's the first function of the first process is to establish the peer-to-peer call. The second function is is to do the video streaming. So after you negotiate with remote device, about the codec information and media information and the IP information, then you can stream this webcam information directly to the remote device. All right, and that's the second function of this process. The last function of this process is also establish a WebSocket interface to the signaling server, and also this remote device also establish the connection, WebSocket connection to the signaling server. So once you can send the control information through this remote device to the signaling server, then to the first process on the Ubuntu board. Then the Ubuntu board basically passes control information to the second process. The second process then controls this Arduino board through the USB serial interface. Then the Arduino board then controls the DC motor to make it move. So the WebSocket is relatively low latency implementation. That's why we use WebSocket for that. And so that's what's running on this Ubuntu board. Arduino board is simple reading what's the command from the UART, and controls the DC motor. So we have 4 motions: moving forward, moving backward, turn right, turn left. All right. Okay, let's test it, see what happens. So suppose this is my server here. Sorry, this is my laptop in the office. Right now I'm just trying to do login here. All right, so let me see. What we should do here. So the website. Oh, by the way, we also in order to make this to work, we also create a signaling server. The server is hosted by OpenShift. It's a free hosting services. And the signaling server is relatively simple. So all it does is to negotiate, get all the media information between the 2 devices and make sure they can talk to each other. And also in the meantime, it maintains a WebSocket channel for control paths. So while one device can send control information through the signaling server to another device. Okay, we can test it out now. So our website name is called webrobot-rhccloud.com, and there's a token here. We can put it like 1, 2, 3, 4. Okay. All right. So you can see that it's starting to do the streaming. So it's actually see the room here, right? So if I click on here, I see like move. You can see the robot is actually moving, right? And in the meantime, the scene is also changing. So let's change that again. So let's see move backward. You can see it's moving, right? It's moving certain way. Let's see move, turn left. For example, it's doing the turn. It's turning too much. I think I need to tune that a little bit. Then you ask it to tune it a little bit to the right, and you can see that it's changing the wheel on the fly. So yeah, so that's this project. I think it's cool, isn't it? Okay, thank you for your time.